Right, friends and fans of Bob's Retro Electronics Workshop. Picking up some heat shrink I see down here because we can't waste any. Okay, what am I going to do today? Well, I've been speaking about a lot of retro Commodore stuff, of course, which a lot of you guys are interested in. Some of us old timers, we had a lot of good times with our old Commodores. So, what I'm doing is I saw a young man on YouTube, and his channel is called Tom's Computer Channel. I think he's Austrian German, something like that from the accent. And he, you know how there's a test harness built by Sven somebody, and it needs a lot of wires and cables and all this stuff. Well, the test harness that Tom was showing that seemed to work just fine was a system that used just dongles. So the project, and he didn't do it either, he built somebody else's, but the dongles project is on PCBWay. So I went on there and looked for this project, and I found it easily. So you can too if you want to order these. These boards are really cheap. And again, I ordered a set of about 5 of them, so I'm not going to need 5. So anybody out there wants to buy one of these, after I build it, I'll just sell it to you for parts and shipping. So what do we need? This one here, the keyboard dongle, just needs one resistor and an LED. They all have LEDs on them. Well, I wanted to use green LEDs, because that's what I've got. And that's a 680, 680, 680, 680. Everything's a 680. I'm going to see if the LEDs I got, these are really old LEDs from the late 70s. I'm going to see if 5 volts is enough to illuminate them. I might need to put a little bit lower resistor in there because of that. And check the polarity. Because the LED indicator on here just has a plus and a minus. It doesn't show the flat spot on the LED, so I don't know which is which. So what we're going to do is we're just going to plug it into a breadboard here. Let me get my own power supply down here. And we're going to dig up a 680. Let's see what I got here. You guys know what a 680 would be? Blue, gray, brown. We'll use all the same kind. How's that sound? So it looks decent. Alright, there's our 5 470s. Those old dull LEDs, a little boost. Alright. So we're going to be installing the 470 in its proper place. Had my big head in the way for some of the videos, so I'm redoing some of these shots today. Yes, the circuit calls for a 680, but our LEDs are a little dim, so we're putting a little bit more current through them. These are nice looking LEDs too. I assume the long lead is the ground because, you know, you always want the ground to be the thing that makes contact first. Ooh, that one fit right in there nice. This has got the spread legs on it apparently. Okay. See if we got enough heat built up in the iron yet. We're going to push that down now from the top to seat it because it's kind of dangling. And let it reset. Like that. These are just power indicators to show you that you're plugged in correctly and making contact, basically. Sounds like I'm having a pig fight in my stomach. Got too much solder on that joint. Suck it up with the... And anyway, there we go. So we're taking this header, which I can give you a parts list from AliExpress. That's how I order these, like everybody does. And I'm going to get my visor on here because I got to be able to see this. Now the first one I'm just going to, well, maybe I'll do one in the center or near each end. I'm going to swamp this with solder, and while it's molten, kind of hold it down on there. And she looks pretty good. My carpet isn't really necessarily the best thing to work on. I'm going to put it on top of the breadboard. And I think I've got it on there nice and straight. It's tilted a little bit, but that doesn't really matter. We want it to sit tight. Trying not to stick my head in the front of it. And a little bit of flux on here never hurt, because you want your solder. Now see, I'm on the pad. And I want to touch on that pin leg so that I'm pressing it down tight to the pad, getting a little solder, and get it good and hot. Need some flux because I'm getting peaking. There we go. Peaking in. I think they're fine. Well, there you go. That's what we end up with. Let's see if I can get you to focus here. How's that? I already soldered all the edge connectors on all of these. Again, you just lay them against the board and swamp them in with your solder, and of course you can lick, and these are big enough and far enough apart you can see that they're not shorting together at all. Now I'm nipping these off nice and close so they don't hang up on stuff. So there's the keyboard dongle. That's all there is to that, because all the loop backs on this on this are built in. There's no resistors or anything to feed it back. So there's the keyboard connector. Alright, so what is next? We have the user port connector. Now, to get this connector on right, you can see that it lines up pretty well with these connectors, but you can see how far apart they are and how thin the circuit board is. So how am I going to deal with this? Well, I'm just going to take something like a hard surface. This is just a heavy plastic lid, and I'm going to just twist and push, and I'm trying to bend these closer to each. I'm going to go over to the edge of the bench here can do this. I'm hanging it over the edge, and I'm going to push down in a parallel force. Push down in a parallel force. I got them plenty tight. Now there's no up or down to this connector. All right, let's go back to the center. I've got them squeezed together quite a bit. So really what you need to do is just wiggle your card in from the end, just like that. Oh yeah, they're touching too. Get the last one lined up. Line them up nice. Now we're going to do one, and then we're going to adjust the angle on it. You know, diddle with it a little bit. And once we get one done, I'll do the other side. Again, make sure they're all centered on the pads, which these look great. And you don't have to overdo it. That's more than enough. Dang, that's pretty close. Let me do one on the other side, opposite that. Make sure you just get it on your connector tab. We'll check again. Oh yeah, nice and straight. It'll look like a professional job that way. And then we're just going to solder them all. Alright, next is the user port. Again, same kind of connector for the edge connector. You have to pinch the connector leads together. I've got some here that aren't soldered in yet. You can see how wide apart they are. So what you have to do is pinch them together. And you saw me do it on the edge of the bench. Laid it on something flat and just twist it down, flipped it over and twisted down, pressing onto it to bend them in. So hey, what do we got here? It looks like another 470, aka used to be 680. Man, that lead is pitted. These have been around a long time. Off the corrosion by scraping that well. As I said, I used to have a little tool that it was like tweezers almost that you could grab onto the leads and scrape it through. Solder up. Make sure you put your components on from the right side, but it's kind of hard to goof that up because these have like outlines of the resistors imprinted right on the top side, and it does say top side. Alright. The LEDs, I got 5 left after this. I got enough to do this one more time. The problem is if I go to fix my clock and I got a bad LEDs, I'm never going to find some that are the same brightness. They're always going to look odd. Yeah, these LEDs have the legs farther apart so that they fit into the standard LED hole for a full-size LED. Different than the ones I was using before. Now my technology for mounting my LEDs in my old board was I just used super glue and put the LEDs into a piece of plexiglass. That's all right. So changing the LEDs is a bit of a pain. Okay, again, sure, like I did with the other one, and just squeeze them towards each other. You can do it with your fingers too. You can just pinch them like so. Again, there's no polarity to these. The cassette port itself has notches, but this doesn't. So now we just wiggle this in here, saw it up and down a little bit, whatever, to get it semi exactly where you want it. Semi exactly, yes. It's a little slanted right now, but that's okay. Once I solder one, we can twist it a little bit. Man, that light's glaring off in this bad. I'll do number 4 right here. Let that solidify. And that turned out pretty dang straight. Soldered up. Just a little trick, if your the leads on your resistors are a little corroded and chalky looking, just take your X-Acto knife and just give them a little scraping like this, and you can see how nice and shiny it gets. Okay, this is a 150 because it's brown for 1, green for 5, brown for 1, meaning 10, and then the gold band means 5% in a carbon resistor. And we're going to check his value. So I will move my meter read over here. We're just going to double check these. It should be somewhere near 150, and 162 is fine. And the 470 that I picked out for the LED reads 469, and the 330 should read 337. So very, very, very close in value. So that's what goes into the cassette dongle. And of course another LED. Those are nicer looking LEDs than I put on my own. I'm going to be selling some of these off because I just don't need them. I had to buy enough components to do them all. So where it says 680 is where I'm putting the 470, because the LEDs are old and they just don't put out the brightness that the newer ones do. So we increase the current by making a smaller resistor, which means it passes more current. I don't know if you're, I gotta scrape this one, I haven't scraped this one much. I don't know if you're familiar with electronics and mathematics, but you can make voltage dividers with resistors in series, and that means connected like this, end to end through a circuit. But the circuit has to drop all the voltage across the elements. If you've got 10 volts here and ground here, that means you've got to have so many volts across this one and whatever's left across the other one. So if these resistors were equal in the middle, if you had 10 volts here, you'd have 5 volts. So that's one way of kind of regulating voltage in a circuit and controlling current at the same time. Okay, so our 330. Put it right in the first notch. These leads are awfully long. I think I'm going to cut them off ahead of time. Just cut them a little shorter so they go into the board nicer. And again, resistors are non-polarized. You can hook them up anyway, but I always like to line up the value stripes so that they're, you know, you're not switching them upside down. It would be like seeing a bunch of words on a document that some of them were upside down and some of them were right side up, you know. And for those of us who can read the color code like another language, that's a little weird. Okay. So there they are. I guess this is right side up for you. All installed, nice and pretty. We'll do the LED later. Now I'm gonna clean my tip. I've been doing this job a very long time. I actually went back to electronics school after being an electrician for almost 10 years. And so when I was 30 years old, I started working in industry. And I'm not going to give away my age, but I was in industry almost 40 years. So I am retired now. And they were all dolled up. And we'll put our little greenie in here. Just like so. Long lead on the negative side. Kind of pull that guy up. There we go. I like that better. There we go. Tighten that up so that it sits in appropriate orientation. Nip the leads, and there we go. We have the cassette port dongle. Now, so we're getting there. There's the third one. Now all that's left, keyboard, user port, we don't have the dongle ready yet, but for the serial board, but we will make that soon. All that's left is the joystick connectors, and how these guys work out, they work out kind of the same way. Is they have these DB9 connectors, and you have to get the solder cup connectors, not the pinch-on ones or the solder tab ones. Well, these are like solder tabs. Yes, they are. So you can put a very fine wire down there and solder it. But if you'll notice, being 9-pin, there's 5 on the top and 4 on the bottom. If you look at this board, there's 4 on the bottom, 5 on the top. So you want to line the 5 on the top up with the board just like that. And heave it snug. And center them up nice. The center one just for the heck of it. There you go. One soldered, one pin soldered. I'm using this because this gives me a target to work on too, so I don't have to keep looking at the camera. And I'm going to do one on the other side. And we'll just finish up the other side. Just let her harden up as she cools. These circuit boards are amazing. These PCBWay is a heck of an asset for breadboarders and experimenters for sure. Now make sure you get a female one, because that's what needs to plug into the joystick ports. Now the cable type connector test bed uses a lot of resistors and feedback, and let's see what the values on this are. 120 Ks. Let's see if I got 120. I've already done one completely, but I'm redoing these because I had such a bad point of view. So we're going to have to do 2 of these. These are the dongles for the control ports, your joystick ports. And these require, again, a 470, the LED to light, and these use 120 Ks. And I dug out the 120 Ks when I did this before, so we will just break 4 of those off in the strip in my little resistor kit here. It was like 14, 15 bucks, something like that. I think I got them right off on Amazon, off on the Jungle site. Alright. As they call it these days. No, I probably could have just used the called for 610s on these. I guess I've said this 100 times. I'm scratching the leads on all these resistors because these resistors that I'm using are old. So I want to make sure they're clean. I'm just going to do one right now for you. Oh, this little bending jig is very handy, because you really don't want to just crank these resistor leads over like and pull on the junction between the wire and the resistor body. That's why I hold it down in the jig and then bend it over the edge. Alright. And we need 2 of these. So I will snip these. I'm going to snip these right off from the... These leads on these resistors are very thin. Okay, I'm just going to snip them off from the tape here. Looks a little. The other ones are nice and clean. Okay. So these are 120K, and I can prove that to you if you like. Put my meter back in the view. Now these were the 4. Remember, these were the 4 color band, because they're more precision resistors and they come in slightly different values than the 5s, 10s, and 20%ers, being 1%ers. So see, that's 120.7 K. If you notice the K right here, it means 1,000 in electronics terms. So 120 K ohm. And this one should be very, because being 1%ers, I'm a 1%er. 121. Better than 1%. Alright. Yeah, I use this disc because it gives me a target to work under the camera for you. Now in the old days we would have just held the body of the resistor and bent the leads down and shoved it in. But I'm trying to be better than that. trying to be a little bit more. See, there's the right orientation. Quarter-watt resistors is what these are. So that's why the leads can be small, because they can't handle a lot of current. If you guys want, I can do a tutorial on simple op-amp amplifiers. They are, you know, they're an amazing device. You can do so many different functions and circuitry with them. When the iron sits hot for a while, it starts building up like corrosion on the soldering tip, almost like slag when you're welding. Touch that one just to give her a touch more solder. There you go. Boy, he's really sucking it up. There you go. And I bought these LEDs years ago to fix my clock. I have a clock that I built that has 168 LEDs in various colors. Let's see, what did I do? I think the outer ring of 60 seconds is green LEDs. The next ring in for 60 minutes are yellow. Now maybe the seconds are yellow. The seconds are yellow. The greens are the minutes, and then jumbo reds for the quarter hours. And when it was running, it was beautiful. The only mistake I made with it is I used a technology known back then as wire wrap. You had your IC sockets that had long legs on them, and you used thin, solid wire instead of soldering to wrap it around all those terminals and jump from circuit to circuit where you wanted it. And unfortunately, I think they've gotten corroded over the years because, you know, it was almost 40 years ago that I did that. Actually, it was 40 years ago, 41 or 42 years ago. But maybe we'll dig that clock out and do some troubleshooting and try to trace out where we're failing, because I designed the circuit myself. I should know, right? All right, well, there's one dongle for the cassette port. Again, we'll put it on my hand so it focuses. And then we have all 5 dongles, except for the, I think it's IEC, that's what it's called. That's just a 7-pin DIN? I can't remember. I ordered it anyway. 6-pin DIN? 6-pin DIN maybe. Same thing that your hard drive cable has on the end of it anyway. And all that's going to do is have a couple of pins shorted together so there's a loop back, so it can tell that the port is there and it can send something and read something simultaneously. So that's how that's going to work. And that's kind of how these work, I believe, too. They send something out, you short across the pins to say, yep, that port works, I can get feedback, so it knows that the chip is actually sending something out and receiving it. We have our 5 little green LEDs. We're going to need more in the future when we build more of these. We'll, when I get back, I will test these guys for you. Alright, that's it for now. We get the dongle back and we'll finish this project up. What you do with these guys is there's a little tab. If you look, it sticks up. It's kind of springy and it's latching behind the plastic here, so you gotta push it down and try not to do that with a knife because you might stick yourself. Let's find something more suitable to push that down with. I got more tools here than I need. Oh, here's this will work really great. The probe for the, and you can kind of push it forward as you do so. Once you get it under there, you should be able. Oh, my finger is sore today. Kind of a difficult task. Here it comes. Here it comes. See it inching out. Well, I'm going to push that in from the back, but I got to find something long and skinny and stiff like a skinny struten driving. All right, pause. So I found a tool to try to push this out from the back because it's tight, and I'm going to hopefully not damage. She's coming slowly. That is one tight fit. There. All right. Now this, I checked the pin out by watching Adrian's Digital Basement building a Commodore 64 test harness was the name of the video. And what we need to do is connect pin 1 to 5 and 3 to 4. Well, if you look at the diagram carefully, 1 to 5 is between the top 2 pins if you're looking at the back like this. So there's 1 and 5, or 1 and 5, and 3 and 4 are these two. So I'll get my head back, make sure I'm not in the way. Because you don't, there's nothing on the front that indicates that. But you got to go from 1 to 5 and 3 to 4. So I'm just going to use, as everybody does, just a piece of resistor lead. We're just going to bend it and stick it in there and solder them up. And you don't really need insulated wire because they're never going to move and touch each other. I don't believe. Let's see, how much do I need? I'm just going to bend a little bit on that guy. Yeah, those aren't very deep. They're not deep at all. So it doesn't even need to be that deep. But this will give us some flexibility to plug it in. I'm going to cut these guys quite a bit shorter. And we'll see how we can make this fit. Flexor down in there. Alright. So there's that one. Elbow right in the way. Alright. Well, I'm not holding this with any helping hands, so this is going to be a little bit awkward, but we'll get her. And you really don't want to put too much heat on these guys, because you'll melt the plastic that holds the pins in in together. Ah, she's hot too, but that looks okay. I'm letting the pins roll across my fingers to suck some of the heat out. Alright. Now what did I say? 3 to 4. So that's a much closer connection too. I'm going to use this little tiny wire. Oh, that's an LED lead. Here we go. I'm going to use the leads off those 120K resistors. It was so small. I should just, another trick I can show you is, you need a rubber band. I'll go get a rubber band. So what you want is a rubber band that's kind of springy. Now I'm going to use it on these dikes, these diagonal cutters. But it isn't enough to, oh boy, that's pretty tight. Maybe I'll back it off. Just enough, so you got just a little bit of bite, and then you can stick it on here, and the weight will hold that pinched. Okay, so I would have done it with my needle nose pliers, but I need them. Now we're going to bend a little horseshoe out of that, and out of that. Now I've got my dikes in there. Alright, that's alright. I've got another set of cutters here that'll work. What's in the hole? Stupid thing is sticking to my needle nose. And this wire is so flimsy, it's... Alright, well, you see what I'm doing, I hope. Turn this over so it grabs up a little higher. Alright, there we go. Can you see that? Well, this has turned out to be the biggest pain in the whole thing. It popped right out. You know what I'm going to do? I'm going to tin the socket. Pain. And then I'm going to try to get it lined up here and start to pop it right in there. Just like that. Go. I actually have these heat sinks too. So you pinch this on so it sucks the heat out too. Alright. Oh, come on. Didn't even solder that one. Gee, this is the biggest pain of all. There we go. There we go. It's not a pretty solder joint, but I think it's effective. Alright. Yep. Alright, and the pins remained straight. So when you're doing this, 1 and 5, if you put it so the horseshoe shape is up, of course across the top 2, and then the bottom and the next one to the left. They short together. Alright. I'm not even going to test continuity because I know this is going to be good. Now we got to put the stinker back together. Well, if you notice, there's 2 little shoulder blocks on this connector, and they drop right into these little shoulder block holes back in the shroud. And the other side of the shroud goes on like so. just like that. And then you slide this mother hucky and line it up, index it correctly. Just push it down hard. And now it's clicked in. Alright, so there is our IEC dongle. Pins 1 and 5 and 3 and 4 are connected together. And that's all there is to that. No active components, no resistors, just shorts. Alright, so here we have it. Go back like just a little bit again. There's our IEC dongle. The user port. The keyboard connector with the straight header, which I have some extras of those too. The I gotta get a glare off in them. Yeah, that's the glare on those. I got wire leads all over the place here. So we'll set that dongle down there. And we have I'll show you this cool little headers one more time. That went on for the you've got pins on this side, sockets on the edge. Alright. So now that we have all the components, let's go take a video of how it tests. So now you see I've got the Commodore up and running. We've got it powered up to test that it works. We got the Commodore down here. Now let's hook up our test bed. Turn the power off. This is the serial cable, so I'm going to take that off. I'm going to take this circuit board out someday and clean it. Put our IEC serial port dongle in there. There is no markings on these control ports, so you can use either one. Now these are the ones we just built. The keyboard connector, you got to be careful. Pin 1 or pin 2 is the blocked one, and that's the missing pin down here. And that does have to go on correctly. So that shoves in all the way. The next would be the cassette port, and then the user port. Now I'm lucky enough that I bought years ago, not too many years ago, I bought this VersaCart, which has the original dead test. It has the diagnostic program that goes with this. It has the 1541 diagnostics, 128 diagnostics, several different diagnostics programs anyway. So I'm going to put that in. I already have it set up for this program that we want. And I even have my arm SID. And so let's see what happens. Alright, 0 page, stack page, both check OK. My timers down here match, so the CIAs are working correctly. It's just doing the RAM test 1 OK. RAM test 2 OK. PLA test OK, but I have a new PLA. Color RAM. Cassette, okay. Keyboard, control ports, everything tests okay. Now it's time for the music. So according to the test harness and the dongle system, this is the way to test your Commodore, and it all says everything works. Now, I told you before in the past that I had to buy a new PLA. When I bought this board, it didn't work, this Commodore, and this is the XC PLA, Rev 1. I forget the name of the man. He can put his name in here if he wants to sell you one. And then, of course, an ARM SID because my old SID, and here comes the phone. So this is the new PLA that I bought, because when I bought this Commodore, it was dead. It was a black screen. I sent the chips out to a gentleman online, which I think he's replied to other posts that I've made. And he supplied me with a new substitute PLA with an FPGA chip on it. It's been working absolutely perfectly. I did build some GAL PLAs. If you need one, let me know. Comment. I'll give you my email address, and I can get you one of those. All tested. Hand built by me. I've been a technician for 38 years. And there's that thing testing again. If you notice the pop sound, I saw a guy who actually uploaded a new revision of the firmware for this ARM SID, and it got rid of the popping. So I'm going to try to do that. It looked like a fairly involved thing. I'm not really a computer PLA EEPROM programmer kind of guy. I was more of a in the trenches building stuff and designing test fixtures and all that. I did program some microcontrollers and stuff. Anyway, so we may be able to update that. Coming in the future for this, you will see me building these. Now that you've seen me build these, I have extra test harnesses. If you would like to have one of these test harnesses, again, contact me via my messages here, and we'll see if we can hook you up, because I didn't build these to make profit. I'm just building them because you have to order a certain quantity to order the parts. So you get a whole bunch of extra parts, and so I've got money and time involved in building these, and I don't need them. I'm going to save a couple of these GALs because these GALs work like a charm. And if I get any more C64s to fix, aka send me some, and we'll fix them together and show you how an amateur does it, because I'm certainly not an expert at testing these. My circuit board here looks pretty dirty. I saw a guy who pulled everything out of here and actually washed it in soap and water with a soft brush. All he took out was the power switch, so we may do that just to clean this up because it does look cruddy. I should have taken the keyboards all apart and cleaned around the keys. I just didn't want to get involved with all those little parts and springs. And it doesn't affect the function whatsoever. And of course, my biggest disaster has been working with these darn 1541s, trying to get this one to read. It reads intermittently, so the heads are good. I think it may be just disc alignment or head alignment. Again, a big pain, because you've got to loosen some screws and turn the stepper motor that's on the bottom under here, these two screws, and you move the stepper motor, which changes exactly where the position of the head is. Alright guys, so that's it for the test harness build and test. And you can see she's still running through. It's on iteration 5. Everything checks okay. And so it would be kind of neat. Let's create a fault. Yeah, that's the ticket. Alright, we're going to turn this off. Probably the easiest thing to do would be to pull out one of the CIAs. I'll be back. Power's off, switch is off, dongles are still in. I don't have one of those fancy pullers, but I do have this tool that has a hooked probe on it. You get in between the chip and the socket here, and just pry up a little bit on each end at a time. It's hard down here on this one. But but you don't want to pry one end way up in the air first. Kind of like that. Alright, we didn't damage anything. We'll set that guy aside. So we took out the one CIA. Let's see what kind of errors we get. Maybe this will give us a clue. Now all the RAM and everything should test okay, but when we get down into here we should get our errors. The RAM and everything should test good because we haven't affected that. And what's going to show up is some of the user ports might not work. Oh, you know what? You see this? The clocks don't match. There's a clue that the CIA is bad. So if you run this and you see that clock's off, that it definitely proves your CIA is dead. Color RAM is testing. Okay, U1. Let's see. I can't see the U1 on this. The silk screen on this board isn't really good. Oh, it showed both of them bad. Shows the SID is bad. And oh, I missed the parts up there. Let's see. We'll let it go through one more time. It's a pretty short test. Turn up the sound just a little bit again. This is kind of neat. I'd like to fix a few more of them. The disk drives are an absolute nightmare though. These are easy because now I've basically got like Adrian's ZIF board, because this is one of those models that has sockets for all the important chips. So these are all the chips that pretty much, okay, cassette is bad. Keyboard is open. Wow, they did a lot of stuff. Serial port, timer, all kinds of stuff bad. Control port's bad. So that CIA chip, see, is an IO board, IO chip, and that's now I gotta try to get this guy back in here without bending any pins on him. Went right in nice. I have deoxided these sockets. I don't know what else I can take out that would show up as an error, or that anything else would even run. I know for the dead test you don't need any of these chips in here. The dead test basically checks the VIC, and it checks your PLA, and it checks your CPU and the RAM area. Everything else can be out of the board. So that's usually the basic test that people start with when you want to start a basic troubleshooting of like a black screen. Is if your chips are socketed, you take these all out, you leave in the CPU. Of course it won't run without a CPU. CPU, PLA, VIC, and then everything else out, and do dead test, and that might blink. And 9 times out of 10, I'll tell you from my experience and what I've been seeing, 9 times out of 10 it's the PLA. But it can be a chip, and a RAM chip, and I actually do have some MOS semiconductors in here. Let's see, what U numbers are these? I can't even see. U23 maybe is a MOS, and U27 are MOS chips. All my RAM is okie except for, that looks like U9, which I can't see the brand, but it looks like Motorola. But it's obviously a factory installed. You can see the way the solder is around the pins. This has never been out. So that was basically what they had in stock. They stuck it in here. It matched the parameters and everything works fine. It's pretty forgiving as far as timing and everything. When you're talking a 1 megahertz processor, the timing isn't like up in the gigahertz time frame. So, that being said, I guess we're done for today again. And I thank you for sticking with me here on my new channel, Bob's retro electronics workshop because everything I work on is going to be old. I've got some old CBs. I've got an old stereo TV stereo decoder, audio decoder that I want to work on. A couple of amplifiers for one of those little crate amplifiers that you carry around for your guitar that's battery powered, so you can go out busking on the street. I got one of those that needs some work. So we'll be getting to those. I might be building some new stuff, I'm not sure. Did I put all my LEDs in backwards? I've got another set that I built here. I might have to pull all those LEDs out. Well, that sucks on ice. I'm going to pull these out, put them in a different area. I'll leave that dongle in there. I'll put these guys back in. Well, there you go. See, I made a goof and I never even did check the LEDs on those. So I guess I gotta go back and do some repair on the shop, but that's no big deal. I'll just pull them out, flip them over. Let's see if our LEDs work on here. Oh yeah, these guys are all working. I can dim the lights. You can see our 1, 2, 3, 4, 5. So, and this dead test. There's another one of those harness setups that dongle harnesses that I'm working on that could be up for grabs if someone wants it. So I thought for sure the short lead was whatever. Oy Gavel. Let's go swap one of them around and make sure that's what it is.